Well, hello and welcome to another quick Python tutorial. In the previous tutorial we talked about the input function and how we can gather information, and through that we kind of alluded to this idea of a variable and all of the different data types that it can take on, whether that be string information like it did through the single input statement up here, or integer or decimal information like it did down here. So now that we have this idea of a variable, we can also start to do things with it, like add them together. And you saw how the addition operation actually worked differently with different types of information. So I felt it be appropriate at this point in time to kind of go through the different operations and what they can do for you and how differently they act when they have different types of information around them. Now I'm not going to write any programs here, but I think it would be best to just simply work in the console to kind of give you a quick idea. So I'm just going to open up idle. I find that the shell of idle is a much simpler place to do this type of scripting so that we can kind of play around with what we need to do. Alright, so let's first talk about the addition operation. The addition operation is pretty simple. You could take two numbers, 2 plus 3, and if you add them together you get 5. No big deal. If you add an integer to an integer, it will always yield an integer result. 5 plus 7 should make 12. As soon as you introduce a decimal, however, you will get a decimal result, 3.0 plus 2. Now it's going to give me a 5.0 instead of the 5 that I had before when I did 2 plus 3. The level of precision of your answer will always match the same level of precision as your inputs, whatever you put into it. So if you put a decimal into it, you will get a decimal out. If you put only integers into it, you will get only integers out amongst most of the major operations that you're going to work with. Okay. Now we did see how the addition sign didn't have to be used just with numbers. We did introduce it also with strings. So if I type something like first plus last, it did actually put them together as first last, and it kind of concatenates them per se in what it's going to do. So the idea of this addition operation being able to be used in multiple different ways is kind of a neat way of using that particular operation. So again, to recap, if you add integers, you get integer values. Decimals, you get a decimal value. If you add strings, you get strings. If you start to mix and match the data types, you might run into some issues. So if I type like 1 plus 2, it's going to have issue with that because it's not going to know what to do with it. So 1 plus 2 is not something you can do if that 1's in quotes and the 2 is not. So you've got to make sure that you match the same data types together, at least something that can get put together. So a decimal with an integer, integer with an integer, decimal with decimal, but again, only strings with strings. Okay. Subtraction is fairly straightforward. So 4 minus 2, going to make 2. 7 minus 1, going to make 6. Again, integers in give you integers out. If I enter in a decimal, like a 6.4 minus 3.1, I'm going to get a 3.3 as my answer. Notice you do get a lot of extra bits here. Okay. It's still doing bitwise arithmetic and breaking things down into binary and trying to build it back up into a representation. Sometimes this happens. It's a level of precision that we don't often have to worry about. It's 15 decimal places out. There's nothing to say here that this 3.3 isn't just good enough. So if you end up with answers like that, don't freak out. Most of the time we're going to round them off to a certain number of decimal places anyways, so you'll never know the difference. Can you do subtraction with strings? Can I take something like an XX, or I'd say any letter, A minus an A? No, because you can't use the subtraction sign amongst two strings. Okay, only the addition sign can you do between two strings like that. Okay. All right, on to multiplication. Same idea here, 2 times 3. The star is your multiplication symbol. If I introduce two integers, I get an integer result. As soon as I introduce a decimal, even if it's just a 2.0, which could be represented as an integer if we wanted to, times 4, it's going to give me a decimal result. Now the one quirky thing that you can do at multiplication, you can multiply strings by an integer. And it will type out that particular string that many times. I mean, if you think about it, it kind of makes sense. Multiplication is just a shorthand notation for addition. This is simply saying, basically take A and add it to itself 5 times over. So it's essentially what I get. And it worked up here, no problem, so why not work down here? Now, one quirky thing that you cannot do is take something like an A and multiply it by a 3.5. It won't let you do it. You can only multiply a string by an integer, something that's not float. And it makes sense, because how are you supposed to get 3.5 A's? It's not going to round it and do anything crazy with it, so it's just going to give you 3 if you type in an integer value. Okay. So that's multiplication, pretty simple, straightforward. If I were to do division, there are many different kinds of division when it comes to programming. Python actually has 3 different division types. It has what we call a single slash, which is real number division. It has a double slash, which is known as floor division, and then we use a percent sign, which is known as remainder division, or often we'll call it modular division or modulus. Let's take a look at all of these. So first, if I do a 2, let's say a 6 divided by 2, okay, using a single slash, notice how I have 2 integers in and I get a float out. This is the first instance where if I do integer arithmetic, it actually gives me a float value, a decimal value. The single slash, the real number division, will always yield a float answer no matter what type of information you put in there. So if I take a 2 divided by 3, I'm going to get a decimal. If I type 10 divided by 5, I'm still going to get a decimal even though it's a 2.0. If I type in decimals, of course I'm going to get decimals out. Divided by 3.4, it's going to give me a decimal out. I don't think it makes any sense to do this with strings. It's obviously not going to work with strings. You can't divide strings out by integers or by other strings at all. So the one thing to note here is that no matter what you do with a single slash, you are always going to get a decimal answer, a float answer. Now, the double slash is a little different. Let's say I took a 15 and divided it by 3. Okay, using 2 slashes. This is actually going to give me an integer result because it's rounding things appropriately and rounding them down. Now 15 divided by 3 is 5, but let's say I did 17 divided by 3. Okay, you would assume it would be something 5 and some change, or 5 point something, but essentially it is just 5. This is what we call floor division, so it simply takes the division and rounds it down to the nearest integer. It will always round it down, so it's really telling you that I have exactly 5 full 3's in 17. Okay, if I were to take a 21 and divide it by 5, it would tell me I have 4 full 5's in 21. Yes, I know it should be like a 4.2, but I only have 4 full 5's. If I wanted the decimal, I would have to take it with a single slash and get myself the 4.2 that I'm looking for. If I put decimals in, okay, let's say I took a 5.5 and divided it by a 2, I'm going to get a decimal answer. It's still going to do the exact same type of math. It's going to say, okay, I've got 2.0 full 2's inside of 5.5. Okay? You're only ever going to get point zeros in this type of math because it's still going to round it down. It's just if you put decimals in, you get decimals out, and that's how it's going to work. The third kind of division is your modulus operator, or the percent key. What that is going to do is simply give you the remainder of your division each and every time. So for instance, let's say I took something and did like 7 mod, or divide by 2. Now, most of the time when you divide 7 by 2, you get something like 3.5, and based upon the divisions I've given you, if you use a single slash, you would get 3.5. If you use the double slash, you would get just a 3. But if I take this, I actually get a 1, because essentially what it's doing is it's trying to figure out what's left over. So over here I've got a little calculator. So if I took 7 and divided by 2, you know you're getting 3.5. The integer part is nonsense to me. What I'm trying to figure out is what is the integer part of this decimal equivalent. So if I were to multiply it by what I divided by, now it tells me that I've got 1 left over as I go through it. this modulus operator will always give you the leftovers as you're going through stuff. So let's say I took a 25 and modded it by 3. Well, let's see. I can figure out exactly how many full 3's go into 25. That should be 8. And then I should have 1 left over because 3 times 8 makes 24. And there's the 1 that's left over. And any numbers that I take appropriately will work this way. So if I did something like 5 mod 3, it's going to give me a 2 because there are 2 units left over once I divide 5 by 3. 5 divided by 3 makes 1.6 repeating. If I got rid of the 1 full 3 that I can get, I should have 2 left over when it's all said and done. So this is kind of like that old version of division you learned back in grade school, where you had to kind of carry and keep track of everything, and you always ended up with some digits left over, and we didn't decimal or make fractions out of them, we just said it was a remainder. This is the exact same thing. This is very useful with cyclical events, or if you're trying to figure out if a number is odd or even, simply divide it by 2 and you can judge the remainder and see if something is equal to a 1 or a 0. If there's 1 for a remainder after dividing by 2, you know the number was odd. If there was a 0 remainder, then you know the number was even when it's all said and done. Can you do it with decimals? Yes, you can. So if I took something like 9.5 and modded it, whoops, let's come over here, 9.5 and modded it by 3.2, it'll do it. It's just the number doesn't really mean a whole lot to you or to anybody, because oftentimes when we're talking about remainders, we're really looking for integer parts anyway, so you're going to be doing this operation with integer type values to go in for the most part. Okay, again, the modulus operator doesn't make a whole lot of sense with strings. You'll use it mostly with integers. The last operation that you should be aware of is the power notation. You can actually raise things to a power. We can go star star 3, and what this simply says is take 2 and raise it to the 3rd power, and so I get 8. It can do square roots. Let's say I took 9 and raised it to the 0.5 power. Okay, that's essentially the square root of 9. It gives me a 3.0. So it could be a quick and easy way to do exponents. And no, you cannot do exponents with strings. It doesn't go that far out. You can do it with decimals. You can do it with integers. If you use integers, you get integer results. If you use decimals, you're going to get decimal results or float results. So it's a nice, easy way to do some arithmetic in Python. Those are your 6, 7 basic arithmetic functions that you have to work with. You can do addition, subtraction, multiplication, and then 3 types of division. Real number division, floor division, okay, or modular division. And last but not least, you have your exponents. So hopefully that kind of sheds some light on some of the arithmetic expressions that we can make and how we're going about calculating certain things for our projects. If that helps, leave a comment below. Otherwise, we'll see you in the next tutorial.